All right, we're on the college algebra final review. All right, we're just going to go through each problem, do it. If you don't need that particular problem, just skip over to the next one. This one here, solve the inequality x squared is greater than 16. Okay, x squared greater than 16. All right, so greater than has a number line that looks like this. You got a value here that it's less than or equal to it, or just less than, and you got a value here it's greater than. So when we have greater than, it goes in opposite directions on this. So if this was an equals and I square root both sides, the square root of x squared, those would cancel. The square root of 16 would be 4, but it could be plus or minus. So here's my values right there, -4 and +4. So we're looking at all the values, negative infinity to -4, and all the values from 4 to positive infinity, which looks like B right here. And you could try some of these values, like in here, like -5. -5 squared is 25, which is greater than 16. And if I try a value in here, like 8 squared is 64, and that's greater than 16. Number 2, solve this by using the quadratic formula. Here's the quadratic formula, and of course I sing a song to remember this. We'll do it again here in a little bit, but find A, B, and C. So A right there in front of R squared is 1. There's B, 3. There's C, -7. So A is 1, B is 3, C is -7. You got to pay attention to these signs right there. Okay. Now calculate the discriminant, B squared minus 4AC. So if I put these numbers in, B is 3, A is 1, and then this is -7. So this looks like 37. 37 is what that is. And so now if I solve the equation, x equals -b plus or minus the square root b squared minus 4a squared, which is 37, all over 2a. So my b was, what was it again, 3? And my a is 1. So I've got -3 plus or minus radical 37, all divided by 2 times 1, which is 2. So here's my answer right there. And you can punch this in just like this, -3. There's a plus or minus option. Type it in like this, or you could separate it like the answers show right here. Okay. Number 3, find the length of a rectangular lot with a perimeter of 134, and the length is 7 more than the width. Okay, so when you see this right here, the length is 7 more than the width, you ask yourself, which one of these sounds like it's bigger and which one's smaller? The length is 7 more than the width, so it sounds like the width is smaller. So we'll let W be our variable for width. That means the length is going to be 7 more than width. It's going to be W plus 7. So I'll put these in. If you look at the box or the rectangular lot, this would be W. This would be W plus 7. So there's my dimensions there. Well, it says the perimeter is 134. So if I add all these up, there's 4 W's plus 7 plus 7 is 14, and that should equal 134. And we just solve that equation. So minus 14, 4W equals, what is that, 120? And divide by 4, looks like W is 30. Okay, so W is 30. There's 30 right there, but don't be a fool and check that one, because see, it's asking for the length. This is the width. See, W, that's why we let W be that variable. So W is 30, which means the length is 30 plus 7, 37. Here's my answer down there, D. Okay. So you could do this and get the answer right, but then pick the wrong one. So we gotta make sure we do this correctly. Okay, number 4. Solve the equation by the zero factor property. All right, so x equals -b plus or minus the square root b squared minus 4ac, all over 2a. All right, so what I like to do is just write this out with parentheses, blank parentheses for each letter, and then go back and fill those in. So like A is 1, see that there? A is 1, so that goes here and here. B is 3, that goes here, and then C is -10 right there. Okay, then there's 1, 2, 3 things to do at one time here. Right there, that's a -3. 2 times 1's a 2 down here. And then in my radical, the discriminant, 3 squared minus 4 times 1 times -10, that's going to be 49. Square root of 49, which is 7. Okay, so there you go. Now, my two answers, -3 plus 7 is 4. 4 divided by 2 is 2. There's 1. -3 minus 7 is -10. Divided by 2 is -5. There's my two answers, 2 and -5. And right here, D. That's right. Okay. Number 5 here. 2 consecutive integers whose product is 56. What that means is like 1, 2, 3, 4, 5. These are all consecutive in order. So we want 2 consecutive, so like the first one be x, and the next one is x plus 1. Okay, we need to figure out what these are. Well, it says the product of these two numbers is 56. So if I multiply these, x squared plus x, if I multiply these two, x times x is x squared, x times 1 is x. This should equal 56, according to what that says. All right, so I'll minus 56. And I get x squared plus x minus 56 equals 0. And now I can do the quadratic formula. All right, so let's do it here. X equals -b plus or minus the square root b squared minus 4ac all over 2a. And so my a is 1, my b is 1, and my c is -56. I'm going to have to write right there. So my three things, that's a -1. Down here, 2 times 1 is 2. And then 1 squared minus 4 times 1 times -56, 225. And the square root of 225 is 15, so this is a 15. All right, so -1 plus 15 is 14, divided by 2 is 7. There's one answer. -1 minus 15 is -16, divided by 2 is -8. Here's my two answers right there for what x could be, and of course we want these. So if x is 7, 7 plus 1 would be 8, so 7 and 8 would be one solution. If I put -8 in there, -8, and then -8 plus 1 is -7, so -8, -7, there's my other answer. And right here, B. Yeah, B. Number 6 here, decide which values of the variable cannot possibly be solutions. Okay, yeah, right here, see, when you divide by something, you cannot divide by 0. That's impossible. So here, x cannot be 0. That's what x cannot be, because 3 times 0 is 0. I'd have 1 divided by 0, can't do that. 9 divided by 0, can't do it. So x cannot be 0. So the answer here is C. X cannot be 0. Here's another one. Decide which values x can't be here. So right here, x can't be 5. There's no way x can be 5 because 5 minus 5 is 0, and I'd be dividing by 0. And right there, x cannot be -6. -6 plus 6 would be 0, and I'd be dividing by 0 there. So these two values right here, x cannot be. So here, D. Okay. I cannot divide by 0. It's not possible. Now, number 8 here. Solve this equation. Okay. Well, we need to look for a common denominator. My common denominator here, I got a 7x and an 8x, so they both have x, but 7 times 8 is 56, so 56x looks like my common denominator. So what I'm going to do is I'm going to multiply both sides by 56x. Okay, so now when I multiply here times this one, the x's will cancel, so 56 times 2, and then divide by 7 would be 16. Then when I multiply to this one, 56x times 2, that's going to be plus 112x. Then when I do it over here, 56x, the x's will cancel, that's going to be 21. Okay. And now solve for x here, so I'm going to minus 16 on both sides. So 112x equals, that's going to be 5, and then I divide by 112. So x equals 5 over 112. And Where is C? Okay. Now you could plug this in and make sure it works. 2 divided by 7, and then put that in parentheses. 5 divided by 12 plus 2. You could check it that way, make sure it works. But that's right. Number 9, give the domain and range. All right, my domain is my x's, like 1, -2, -7, and 6. Looks like these, or these. Not this one, so B's out and D's out. My range is the y, so I got 8, -8, -5, -8, which looks like this one and this one. So it's one of these two. This says yes, that says no. It says, does the relation represent a function? All right, in a function, each x is paired with only one y. Each x is paired with only one y. So if we look at this x here, 1, it's paired with 8, and I don't see 1 paired with anything else. -2 for x is paired with -8. I don't see it paired with anything else. I do see a -8 over here, but that's y's. It's okay to have repeats on y's. You just can't have repeats on x's. So this is a function. -7 is paired up with -5 only, and 6 is paired up with -8 only. So the answer is A. Now what would make it not a function is if I had like 1 with 5 over here. I'd have 1 with 8, and now here I have 1 with 5. That makes it not a function. Okay. Number 10. Does this relation show a function? Okay. We got the vertical line test. The vertical line test says if you draw a vertical line and you touch it twice, it's not a function. It can only touch it one time, and if I draw a vertical line, no matter where I draw it at, it will only touch it one time. So this passes the vertical line test. Yes, it is a function. And this next one, though, however, it fails the vertical line test. If I draw a vertical line, see, it touches it 3 times. Can't do that. It only can touch it once. So this is a big fat no. It's not a function. Okay, graph this one. Okay, I'm going to graph this equation. All right there's my slope, and right here, this is my y-intercept. So that means it goes down 2. So like down 2, it should cross right here, down 2, which this one don't. It crosses right there. See, that could be it. Right here, nope. Right here, yes. So it's got to be B or D based on just the y-intercept going down 2. But this is 1/4, which means it goes up 1 and it goes over 4. So if I go here and I go up 1 over 4, that'd put me right there, and I don't think this is it. See here, if I go up 1 over 4, see, I hit it right there. This is it right here. D. Use my answer. All right, graph this one. Same thing. Here's my slope. This is my slope. And this is my y-intercept. This should go up 2, which up 2 there. Could be that one. Nope. Up 2 here. Nope. Could be this one. Up 2. Nope. So it's got to be A or C this time, just based on the y-intercept. Now if you look at the slope, -1/2, -1/2 means it goes down 1 and then it goes over 2. So see, this goes down 1 over 2. Nope. See here, down 1 over 2 right there. This is it. C. Right. All right, number 14. Write an equation of the line that passes through these points. Okay, so first you got to find the slope. Y from point 2 minus y from point 1 over x from point 2 minus x from point 1. This is the slope formula. All right, so this will be point 2. Here's point 1. So the y in point 2 looks like 4. Minus the y in point 1, well, there's 5. On the bottom, the x in point 2 is 0. Minus the x in point 1, well, that's a 2. So I got 4 minus 5, which is -1. 0 minus 2 is -2, and the negatives will cancel. And this is 1/2. So there's my slope right there, 1/2. Okay, which means I have this, y equals 1/2 x plus b. I got to figure out what this y-intercept number is. Okay, well what I'm going to do is y equals 1/2 x plus b. I'm going to take one of these points here. I'm going to take 2 and 5. I'm going to put 2 for x. I'm going to put 5 over here for y. Which gives me this. 5 equals 1/2 times 2 is 1 plus b. And if I minus 1 on both sides, b is 6. Okay, I've made a mistake because I don't see that on here. Oh, 5 minus 1 is 4. I added 1. All right, there you go. So b is 4. All right, so I should have 1/2 x plus 4. Right there, D. Yep, right here. Yeah. Okay, had a little brain fart right there, I guess. Huh. All right, right here we got to graph this function. All right, this is a piecewise function. This is when x is greater than or equal to 1. And this is when x is less than 1. Right here, greater than or equal to 1. If I put 1 in here, if I put 1 in there, I'm just going to get -4. Okay, so I should have that point, and because it's equal to, it's going to be colored in. So I'll go to 1, -4. Well, it's not even on this one. This is out. 1, -4, but it should be colored in. This is out. 1, -4. There it is, colored in. This could be it. 1. Look here. It's got to be that one, just based on that 1 point. Okay, but let's just suppose that we had 2 options that did work. Okay, then I got to pick a value that's less than, see, greater than 1, which would be like 2. And if I put 2 in, I get -4. So see here, 2, -4 is on the line there, so that's good. Okay, so that checks out. Now, what if you still didn't know which one it was? Well, you go down here, you put 1 in it. But see, it's less than 1, which means it's going to be an open circle when I draw this one. So if I put 1 in, -2 minus 1 would be -3. So I should have 1, -3, and it should be open. See 1, -3 right there, and see how it's open? So this is clearly the right answer right there. Number 16, find fg, which this means f times g of x, when f of x is this, and g of x is, here's my, so I got to do 4x plus 4 times 3x plus 9. I got to multiply these. Well, let's just build us a box. I got a column for the 3x, got a column for the 9. We'll take 4x plus 4, put it to the side. So right here, 3x times 4x is 12x squared. 4x times 9 is 36x. 3x times 4 is 12x. And then 4 times 9 is 36. Those two add together, so it looks like 12x squared. 36 plus 12 is plus 48x, and then plus 36. That looks like the answer right there. Looks like C. All right, yeah. Number 17. Find the domain of this when f of x is this and g of x is that. So, if I do f minus g, I'm going to have 3x minus 6 minus 7x minus 8. So I need to distribute this minus into here, which means I'm going to have this turns into a plus. That makes this a negative, and it makes that a positive. So 3x plus -7x is -4x, and then -6 plus 8 would be a positive 2. And so here's what I get when I do this. Well, there's no issues with this. X can be anything. So this can be negative infinity to positive infinity. Now, what would give you issues if you had something like -4x plus 2 over x minus 5. Okay, and you have this in the bottom down here. Well, that means x cannot be 5. And there's an issue with the domain. There's a value x cannot be. Okay, or if you have a radical, like if you have a radical of x plus 2, okay, that means x has to be greater than -2. -2 plus 2 is 0. It could equal 0, so it's greater than or equal to -2. X can't be -3 though, because -3 plus 2 would be a -1, and I can't do a radical of -1. So these are issues that affect your domain when you have a denominator like this with the x in it, or if you have a radical with the x in it. It affects your domain. Number 18, sketch the graph of this parabola. Okay. So we see here x minus 2, that means x is positive 2. And I got -6 here. This should be the vertex point of this parabola. So 2, -6 is right here. That could be this one. What?
I said third and final try I got in your room.
Oh. You can see these other ones don't have it, so it's got to be this one right here. What you need?
I don't have your signature sheet from Wednesday's training.
Oh.
So, I don't know what happened to it, but I couldn't find it. It was the 28th, 428. Thank you. Sorry to bother you.
So clearly this is the answer because it has the right vertex. Remember now, on this right here, it has the opposite. So since it says -2, it's going to the positive 2 sides. So it goes this way. And this does whatever it says. Since it's -6, it goes down 6. Okay. Well, if I had this one right here, see, this is back this way 2, and then down 10. So that's going to be x plus 2, since it goes back this way 2 squared. And then it's going to be -6. Okay, because it goes down 6. There's my vertex right there. -2, 6. -6. Graph the polynomial function. Okay. All right, so here we go. X squared. We got x minus 3, and we got x plus 2 squared. All right, right here, x equals 0. Right here, x equals 3. 3 minus 3 is 0. Right here, x equals -2. -2 plus 2 is 0. So there's my 0. Okay. Now this has multiplicity 2. Since it's squared, this has multiplicity 2. This one here doesn't have one, so it's just multiplicity 1. And this, of course, this is squared, so that has multiplicity 2 as well. Which means this. If you have an even multiplicity, like these twos, it's going to touch and turn. It's going to bounce. This is an odd multiplicity, which means it's going to pass through. All right, so it means like at 0, it should bounce off the 0. Like here's your 0 right here. It should come hit it and bounce off like this, which this clearly does right here. You can see it bounces off of it there, and it does it right here. This one does it right there. And this one, so all these bounce off at 0, so all of them have that. Let's look at this one. At -2, it should also touch and turn. So at -2, all right, -2 right here, don't even hit that one, so that's out. -2 there, right there, see, it bounces off of it there. So this could be one of them, or this is a possibility. It don't hit -2 there, so that one's out. And then -2, see, it does bounce here. And of course, 3, it should pass through at 3 right here. See how this does? See how it just passes right on through? Same thing here at 3, it passes right on through. So it's clearly one of these two right here, B or D. Well, you got to look at the end behavior. The end behavior, you got to look at your lead coefficient, lead term. Since this is factored out, it's going to be a product of the lead terms. So like this first one right here is x squared. This one right here, the lead term is x. This one here, the lead term is x, but it's squared, so it's x squared. Okay, so if I multiply these, I get x to the 5th. I multiply these right here, x to the 5th, which means it's positive, so the right side is going up. And since it's an odd power, the left side does the opposite. It's going to have to go down. And so here's what you should have in your graph. So on the left, it goes down, which clearly is what this does. And on the right, it goes up. See, this is the opposite. Answer is B. Okay, so that took a little bit of time there, but it's not really difficult. Sketch this one. Okay, right here we see x plus 4. X cannot be -4. So we have a vertical asymptote at -4. See, like right here. There's a vertical asymptote at -4. And here's one. But this is positive 4. That ain't it. And same thing here. That ain't it. So it's got to be A or B. Okay, now look at your horizontal asymptote. The horizontal asymptote depends on the degrees in the numerator versus the denominator. This is degree of 1. That's degree of 1, which is the same. So that means I divide the lead terms. This 1 here divided by that 1. 1 divided by 1 is 1. So y equals 1 is your horizontal asymptote, which looks like right here. See, this one here is -1, so this is not it. The answer is A. Okay. Number 21 is f is 1 to 1. Find the equation for its inverse. Okay, this is 1 to 1. So there's 4 steps. Step number 1, you write y for f of x. So that means we'll have y equals 2x plus 8. That's really easy. These first couple steps, you can just do them all together. Here you swap x and y. So that means I have x equals 2y plus 8. So now I have this. All right, so that's the first 2 steps. Okay. Step 3, you solve for y now. So I'm going to solve for y, which means I'm going to minus 8 on both sides, which gives me x minus 8 equals 2y. That goes away, and now I divide by 2. X minus 8 divided by 2 is y. So we solve for y. Now step 4, change y to f inverse of x. So right here, this is f inverse of x, and it equals this x minus 8 all divided by 2. And there's my inverse function, which you can see right here. C is the answer. C. Okay, number 22 here. 22, write an equation for this graph. All right, this is an exponential function. We know that because the tail is horizontal. Exponential, the tail is always horizontal. All right, now notice my asymptote. See, that's down 2. That means I'm going to have a minus 2 here. So like it could be one of these two right here. This is out and that one's out. Okay, now what I got to do is I got to find the point that's 1 up from the asymptote. So here's my asymptote, and 1 up would be this one right here. Normally that point is right here. Okay, it looks like it's gone to the left 1. So this thing is moved over to the left 1, which means I'm going to have x plus 1. So it looks like right here, see, x plus 1 in the exponent. It's x plus 1, and it's gone down 2, which means minus 2. Here's another one, 23. All right, see how my asymptote's up 1, so I'm going to have a plus 1, so these are out. It's got to be one of these two, because it's up 1, so plus 1. And then look for the point that's 1 up from the asymptote, which looks like it's right there. And notice it's usually here, so it's gone over to the left 2, which means I should have x plus 2 right there. A. This is out. Okay, 24. The amount of 215 milligrams of isotope is given by this equation, where t is time in years since the initial amount of 215 milligrams was present. Find the amount to the nearest milligram left after 20 years. All right, so 20 years is my t. So I'm going to put that in for t right there. So I'm just going to type this equation and put that in for t. So it looks like this, 215. And then I got e right here. And I got negative 0.018 times my t, which is 215. I'm sorry, 20 years. Sorry about that. 20 years. There you go, 150. D. Straight up 150. Number 26, solve this equation. Okay, I got log base x plus 9 of 10 equals 1. Okay, so what I need to do is, since that's a log, I need to raise it as an exponent. X plus 9. X plus 9. Which makes this cancel, so 10 equals x plus 9 to the 1 power, which is just x plus 9, so minus 9 on both sides. I get x equals 1. So, looks like C here. Okay, number 26. Graph this function. Okay, we don't have the graph utility. I don't have the computer on, but okay, so this is a log, which means my tail is going up and down. And I got x minus 4. And I see this minus 4. It's going to move it this way 4. So I got 1, 2, 3, 4. My asymptote's going to be right here. And then my tail and does this right here. Okay. So this minus 4 is going to move it to the right 4. Okay, now my domain and range. Well, range is negative infinity to positive infinity right here. Not this one. Not this one. Right here. That's range. It goes down forever and it goes up forever. As this thing goes up, it's going up forever. So it's a B or D. Now what about my domain? Well, see, I don't have any values on this side of that asymptote because I can't cross it. So it looks like it goes from 4 to infinity. So it looks like D right here. All right, 27. Graph this one. All right, now look here. See this one here, this plus 3, that's going to make it go up 3. See, making sure you know the difference. This makes it, because it's in parentheses here with the x, it's going to go to the right 3. This is going to go, to the right 4. This is going to go up 3. So this kind of looks like this one here. No, it's not this one. Oh, wait, no, wait a minute. This is a log. This is not a log. Yeah, this is not a log. This is a logarithm. That's a logarithm. Now, if it's up 3, that means usually we have this point here, so that goes up 3, which kind of don't look like it right there. Right here, 1, 2, 3. It looks like this one. Looks like D. Okay. Usually this point we have is at 1, 0 for a logarithm. 1, 0. So it goes up 3, which moves it up there. Number 28. Match the function with this graph. Okay. Well, this minus 2 means it's going to go to the right 2. This is a logarithm, so it's going to have a tail going down like this, but it's going to be moved over 2, which looks like it could be this one. Not this one. Could be this one. Not this one because it's on the axis. So it's got to be A or C. But now here's the thing on this. The tail is up. See here? The tail is up on this one, which means it should have a negative in front. Well, it don't. So this one's out. This is over here. See, the tail is down. Okay, 29. Use the properties of logarithms to rewrite this. Okay, so we've got a product here, so that means I can split this up. Log base 4 of x to the 3. And since it's a product, plus log base 4 of y to the 9. Then I'm dividing by this, so it's going to be minus log base 4 of 5. Okay, so if you have a multiply, it's a plus, and then divide, which you're dividing by the 5, so it's going to be minus. Okay. Now, these exponents can come out in front as multipliers. So this 3 is going to come out in front of him. This 9 right here is going to come out in front of him. And so it looks like this. 3 log base 4 of x plus 9 log base 4 of y minus log base 4 of 5. That should be it. So it looks like 3 log base 4 of x plus 9 log base 4 of y. That's B. All right, 31. Suppose this function right here models salinity of ocean water to depths of 1,000 meters at a certain latitude. Salinity, how salty the water is, changes as you go further down. That's what this means. In the model, x is the depth in meters, and f of x is the grams of salt per kilometer of seawater. Approximate the salinity to the nearest hundredth when the depth is 775 meters. So here's my depth right here. That's D. Okay, and depth is x. See, x is depth. So I'm just going to put that in for x right here. So I'm just going to type this in. 30.8 plus 1.3 log. I'm going to have 775 plus 1, which is 776. I'm just typing it in. So here's how you type it in, how it looks. 30.8 plus 1.3 log 776 34.55, which is 34.56 right here. Hey, there's my answer right there. It's in good shape. Number 32, solve this system by substitution method. All right, look here, x equals this. So I'm just going to take 9y and put it for x up here. So I have 9y minus 8y equals 1. So that's 9y minus, that's 1y equals 1. So there you go, there's y. Y is 1. Now let's plug it in right here. So I have x minus 8 times 1 is 8. All right, so I'm going to solve this one. So I add 8. X equals 9. There you go. Then my last one on here. Give all solutions of the nonlinear system of equations. Okay, so we've got a nonlinear one. So what I'm going to have to do is I'm going to have to add a y here on both sides. X equals 1 plus y. And I'll plug this in for x in the other equation. So I have 1 plus y squared plus y squared equals 145. Okay. I'll call back in 5 minutes.
Oh, yeah, he'll call you back in 5 minutes.
So I got to do 1 plus y times 1 plus y.
See you, Jason.
1 plus y, 1 plus y. That's going to be 1. That's going to be y times 1, y times 1. This is y squared. So I got y squared, 2 y's, and then plus 1. Plus y squared equals 145. All right, I'm going to have to minus 145, bring it over here. And then that gives me y squared and y, so that's 2y squared plus 2y's. And then 1 minus 145 is negative 144. Okay, a little bit sloppy here, I'm sorry, but so I'm going to do quite now. I will notice here all these are divisible by 2, so I can divide them all by 2, which gives me y squared plus y minus 72 equals 0, and that might help it come out a little bit easier. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so my a is 1 right here, so that goes in here. My b is a 1, and my c is a negative 72. I have 1, 2, 3 things to do at one time here. So it means I got a negative 1. 2 times 1 is a 2 down here. And then 1 minus 4 times 1 times negative 72, that's going to be 288, 289. And I got the square root of that, which is 17. All right, so negative 1 plus 17 is 16. 16 divided by 2 is 8. There's one answer. And then negative 1 minus 17 is negative 18, divided by 2 is negative 9. There's another answer. Okay, so these are my x values. Now I got to figure out the y value that goes with them. So like right here, okay, I put x equals, but it's supposed to be y. These are my y values. So if I put that in for y right there, 1 plus 8 would be 9. So this is 9, 8. There's one solution. If I put negative 9 in for y, 1 plus negative 9 is negative 8. So negative 8, negative 9 is one solution. And these are my two solutions. This looks like B right here. Negative 8, negative 9, and then 9, 8. Yep, B. And then that's it. All right, so this is the review. Study this review. You can watch this video as much as you want, or as little as you need, but just study the review, make sure you know how to do it, and you'll be fine on this test. So have a good rest of the day.